Machine learning using R, boosting with many categorical features. I want to introduce an R package called CatBoost. Here's a brief overview. CatBoost is a gradient boosting library with an R interface built for classification, regression, and ranking, and excels with many categorical features. It natively encodes categorical variables and uses ordered boosting to limit overfitting and reduce target leakage, avoiding heavy pre-processing like one-hot encoding. The R package is used via library CatBoost, then trained with catboost.train and scored with catboost.predict. Main tuning options are iterations, depth, learning rate, and loss function, for example, log loss, RMSE, or multi-class. Built-in tools like catboost.cv or catboost.get feature importance supports cross-validation and feature importance analysis within our workflows. So let's get started. First, I want to set a random seed. Okay, so here, random seed, and then create 200 observations, 1,000 predictors. These predictors, some are binary, some are 3 levels, multinomial, and then create the data set, and then create log odds, and then probability of success, and create an outcome, which is a binary. And so here is the first few rows and columns. I say the first few rows and several columns and the outcome. Okay. All right. So we want to use CatBoost, and the installation you need to use Devtools and then install GitHub. So you directly install this package from GitHub, because when I try to install this using install.packages, CatBoost, it says it's not available for this version of R. Okay, so it takes a little bit extra work to install it. So then now we load it in. We create a categorical feature variable, which is 1 to 1,000. And then we convert all categorical column to factors. And this is important. Otherwise, CatBoost would not recognize the variable. It must be entered as factors. And then we can create a CatBoost object using this catboost.load pool, data equal to x, label equal to df at outcome. So you need to massage the data into this called pool structure. And then you can define parameters and train model. So you param is the list, loss function. Now we use the log loss, iterations, 100 iterations, steps equal to 6, learning rate is 0.1, and verbals equal to 10. And now we can train the model, catboost.train, using the train underscore pool, the data in the pool format, and parameters equal to params. And you can see below, it print out the iterations. Okay. And then we can use the fitted model to make predictions using the catboost.predict. And then we put the cat model, the train pool, and the prediction type equal to probability. So we want to calculate the predicted probability, and then we want to also predict the class labels. Okay, so here you use the same function, CatBoost.predict, but then prediction type is class. So these are props and prep labels. Both are vectors. So let's print out the first few, like 6. You got probabilities and you got class labels. And then you can do cross-validation. So it's a little bit tricky. I tried a few times to make it work. So we can use the CV parameters, use loss functions, log loss, iteration 100, depth is 6, learning ratio 0.1, random seed 1, 2, 3, and verbal is equal to 10. And then we can use this catboost.cv. You can see it's coming up. So you can see it has say 0, 3, 1, 3, and 2, 3. So by default, it just went with a smaller number, 3. So it's the threefold cross-validation. And you can see here, it has the test and the total, I think, time, and also the remaining. And here, the best test is the lowest or best cross-validation log loss achieved on the validation or the test. Okay, and best iteration is where it was achieved. So this tells us the optimal test, the validation score was achieved at iteration 14, and after that it just become worse. Okay, so this is for the second fold, the best iteration is 62, and for the third is 32. And then we can actually print out the result here. Since remember when we specify the parameters, iteration equal to 100, so this cross-validation result is has 100 rows. You can see the 100 iterations. So what you want to look at here is the test.log loss mean and test.log loss mean, train.log loss mean. So you want to compare these two columns. If they are different, especially when the train log loss means start to decrease, but the test log loss mean stay about the same or decrease very slowly, or you can see there's a big divergence between the two. That usually means they are overfitting for the model. Okay, and the test.log loss std, the standard deviation, and train.log loss standard deviation, you want these standard deviation to be small, so that that means there's a stability or less variability of the mean values. Okay, so here both column, I think especially for the train log loss.std is very small, but for the test.log loss std, it's started small, then start to increase over time, over the iterations. So this kind of the pattern give you. So based on this output, there may be some overfitting of this model. So if you want to continue to improve the model, you probably want to do some additional hyperparameter tuning. Just make sure you get a good model. Okay. Thanks for watching, and I'll see you at the next video.